Hi everyone, I am Pramod, currently pursuing in SRIT CSED section. Today I am going to present a small video presentation on the topic Rolle's theorem. Rolle's theorem. Introduction to Rolle's theorem. Rolle's theorem is a fundamental result in differential calculus. It states that if a function is continuous on a closed interval and differentiable on the open interval, then there exists at least one point where the differentiative is zero. The theorem is named after the French mathematician Michel Rolli, who proved it in the late 17th century. Preconditions of Rolle's theorems. The functions must be continuous on the closed interval a comma b. The function must be differentiable on the open interval a comma b. The function values at the endpoints must be equal, i.e. f of a is equal to f of b. Statement of Rolle's theorem. If the conditions are satisfied, then there exists some open interval c in open interval a comma b such that open interval f of c is equal to 0. The point open interval c is where the tangent to the curve is horizontal. This point indicates a local maximum, minimum, or a point of inflections. Geometric interpretations. The theorem implies that the graph of the function has a horizontal tangent line somewhere between close open interval a and open interval b. It can be visualized as a smooth curve starting and ending at the same height. The curve must have at least one flat point where the slope is 0. Example of Rolle's theorem. Consider the function f of x is equal to x2 minus 4x plus 3 on closed interval 1 comma 3. Since f of 1 is equal to f of 3 is equal to minus 0, the derivative of f of x is equal to 2x minus 4, setting f of c is equal to 0 give c is equal to 2, which lies in one open interval 1 comma 3. Significance in calculus. Rolle's theorem is a special case of the mean value theorem. It helps establish the existence of stationary points within a interval. The theorem is used to prove other important results in a calculus such as the mean value theorem and Taylor's theorem. Applications of Rolle's theorem. Used in analyzing and behavior of functions and their derivatives. Helps in finding points of local maxima and minima. Utilized in numerical methods and in proving inequalities. Limitations of Rolle's theorem. The functions must be continuous and differentiable, limiting its applications to smooth functions. The condition f of a is equal to f of b must be strictly safety. The theorem does not satisfy the number of such points where the derivative is 0. Summary of key points. Rolle's theorem guarantees a point with zero derivative under certain conditions. It requires the function to be continuous, differentiable, and equal at endpoint. The theorem is fundamental in understanding the shape and behavior of functions. Conclusion and further study. Rolle's theorem is a cornerstone of differential calculus with wide ranging applications. It provides insight into the existence of stationary points on curves. Further study can include exploring the mean value theorem and Taylor's theorem, which build upon Rolle's theorem. Thank you.